Bismillahirrahmanirrahim. We discuss echelon form and reduced echelon form. What is meant by echelon form? A matrix A said to be in row echelon form if it satisfies the following condition. Number first, the number of zero increases row by row before the first non-zero element of each row. The number of zeros increasing row by row before the first non-zero element of each row. What is meant by that sentence? For example, we have a matrix A that is 0, 2, 3, 4. 0, 0, 2, 3. 0, 0, 0, 4. That is row 1, non-zero row. That is R2, non-zero row. That is R3, non-zero row, because they have some element, nor all the element of each row are 0. If all element of this row of any row are 0, all element, then this is called 0 row. So look at this. The number of 0 increases row by row before the first non-zero element. This 2 is the non-zero element of row 1. And look at before that there is 1 0. So the number of 0 increases row by row. Look at R2. The non-zero element of R2, that is 2. That is the non-zero element of R2. And look at the number of 0 before these two. These are 2 zeros. So the number of zeros increasing row by row. In the first row there is only 1 0. In the second row, before the non-zero element, there are 2 zeros. And look at this 4, that is non-zero element of row 3. Non-zero element of R3. And before that there are 3 zeros. So the number of zeros increasing row by row. So the number of 0 increases row by row before the first non-zero element of each row. So if we apply that property on that matrix, so look at this non-zero element and there is only 1 0 before that. In the second row, the non-zero element is 2 and there are 2 zeros before this number non-zero element. In the third row, that is non-zero element and there are 3 0 before the non-zero element. So the number of zeros increasing row by row. Look at another example. If we have, let's suppose that is matrix B, 1, 2, 3, 0, 1, 2, 0, 0 and 0. Now this is row 1, non-zero row, that is R2, non-zero row, that is again non-zero row, and that is 0 row, R3, all elements are 0, so that is 0 row, non-zero. The other two are non-zero and that is 0. And that is non-zero element of the first row, non-zero element. Of row 1. And there is no 0 before that element. Look at the second one. Let's suppose that is 2. the non-zero element of R2, that is 2, and there is only 1 0. There is no 0 and there is only 1 0 in the second row, so the number of 0 are increasing row by row, and that is 0 row. So that is also echelon form. That is also echelon form. And the second property is all 0 rows are always below non-zero row of a matrix. All 0 rows. So look at in this example, the 0 row is below. The 0 row is below the non-zero row of matrix B. So if any matrix satisfies these two conditions, so we call them, that is echelon form. Otherwise not in echelon form. Another example, let's suppose C 0 1 2 4 0 0 0 2 0 0 0 and 0, and that is 4. Look at again, this is the non-zero element of row 1 and there is 1 0 before that element. This is the non-zero element of R2. There are 3 zeros, so the number of zeros are increasing row by row, and that is the non-zero element of R3. And look at the number of 0 increasing row by row, so that is echelon form. And remember that the non-zero element of each row, the first non-zero element of each row, that is called pivot. Pivot element of that row. Similarly, that is pivot of row 1, that is pivot of row 2, that is pivot of row 3. In this case, the pivot element is 1 in row 1, and row 2 pivot element is 2, and similarly in that example the pivot element of row 1 is 1, pivot element of non-zero element, that is 2, and that is 4. So how we define the pivot? So the first non-zero element in each row in echelon form is known as pivot element of each row. Again, the first non-zero element in each row in echelon form is known as pivot element of each row. Now, reduced echelon form. A matrix A is said to be in reduced row echelon form if it satisfies the following condition. Number first, the matrix A must be in row echelon form. It must be in echelon form or row echelon form. If this is not in row or echelon form, so so we cannot say that that is in reduced echelon form. The second one, the pivot element of each row must be 1. The pivot element of each row must be 1. And number third, every element in the pivot column must be 0 except the pivot element 1. Every element in the pivot column must be 0 except the pivot element 1. Look at example, we apply these. An example, let's suppose we have matrix A, simple identity matrix, that is reduced echelon form of, let's suppose we are taking 3 by 3 matrix 1 0 0 0 1 0 0 0 1. So that is echelon form. Why this is echelon form? Because this is the first non-zero element. and the number of zeros increasing row by row. In the first row, before the non-zero element, there is no zero. In the second row, before the non-zero element, this is 1 0. In the third row, before the non-zero element, there are 2 zeros. So the number of zeros are increasing row by row, and that is echelon form. So that is the first one. The matrix A must be in row echelon form, so that satisfies. Number second, the pivot element of each row must be 1. So look at, I told you the first non-zero element of each row, that is pivot element. So in this case, the pivot element is 1. The pivot element, that is non-zero element of the second row, that is the non-zero element of the third row, so they are equal to 1. So the pivot element of each row must be 1. The second condition is satisfied. The third one, every element in the pivot column means, look at, this is the first one, this is the first pivot element of the first row, so that's the first column, so must be 0 except the pivot element 1, so that is 1, and look at the rest of the element of that column are 0. In the second column, the pivot element is 1, and look at the rest of the element are 0. In the third, the pivot element is 1, the third column, and look at the rest of the element are 0. So every element in the pivot column must be 0 except the pivot element 1. So that is called reduced echelon form. That is reduced echelon form. This is another example. 0 1 0 2 0 0 1 3 and 0 0 0. So look at, that is the pivot element, non-zero element, and the number of 0 before that pivot element is 0. That is the first non-zero element of the second row, and look at the number of 0 before the pivot element are 2. The number of 0 in the first row, there is only 1 0. In the second, there are 2. So the number of zeros are increasing row by row. So that is echelon form. So the matrix A in echelon form, the first condition satisfied. The second, the pivot element of each row must be 1. So that is the pivot element of row 1. And that is equal to 1, that is equal to 1 of the pivot element of row 2. And the third, every element in the pivot column must be 0, so that is the pivot column, that is 1, and look at the rest of the element of that column are 0. And the second, that is 1, and the rest of the element of that column are 0, so that is reduced echelon form. Another example, 1 0 2 0 0 1 0. So look at, that is the first pivot element, and the number of zeros are increases row by row, so that is echelon form, row echelon form, and the pivot element are equal to 1. And look at the number of zeros in that pivot column, that are 0. That is the pivot element of that column of second row, and the second column, that is 1, and the rest of the element of 0. That is the non-zero element, or first non-zero element of the third row, and look at, that is in the column 4th, and the rest of element of that column are 0 except the pivot element. So that is also in reduced echelon form. So a matrix is said to be reduced echelon form if it is satisfied the following 3 conditions. The first, the matrix A must be in row echelon form. The pivot element of each row must be 1. Every element in the pivot column must be 0 except the pivot element 1. So that is about the echelon form and reduced echelon form. And it's okay. Thank you.